Hi, and welcome to Chem 300 Lab. This week, we'll be doing the percent composition of a mixtures lab. So let's get started. So the purpose of this lab is to develop an understanding of separation theory by quantitative determining the percent composition of a mixture through physical separation method. So basically, we are having a mixture, and we need to determine what is the percent composition of each of the individual component in this mixture. Now, the term percent composition is something that we have learned from lecture already. We have learned already that in a compound, that it consists of different types of elements, we can determine the percent composition of an individual element by taking the mass of that element and divided by the total mass of the entire compound, multiplied by 100. So this would then give us what is the percent composition by mass of an element in a compound. So a physical mixture, is basically very much in the same way. It consists of different components. And now we can also determine what is the percent by mass of each of the components. And the percent composition by mass of each of the component can be determined by figuring out the mass of each of the individual component, divided by the total mass multiplied by 100%. And that is what we'll be doing in this lab. So overall, here is the overview of this lab. First, we will create a mixture by weighing out the different amounts of the different components. And there are three types of components that we will use to make up this mixture. First, iron filings, and second, sand, and third, sugar. So these are the three components, and we'll be weighing out a very specific amount of each of this component. And now that we know how much of this component of each of this component that we have thus weighted out to make a mixture, we can then determine the percent composition of each of this individual component. And once we have made this mixture already, we'll then take out a small section of this larger mixture right here, and we'll then separate them. We separate these three components by using the differences in their physical property. And then after we have the three components separate already, we'll then determine the mass of each of the component, and then we can calculate their experimental percent composition. So there should be two types of percent composition that we will see here in this lab. One is the actual percent composition, and that is obtained by the amount that we weighted out to make up this mixture. After we have this separate already, of course, then we will not be able to recover everything, and there'll be some percent error. So in the end, after we have separate the component and determine their percent composition, this would then become our experimental percent composition right here. And we will then calculate the percent error by comparing the before and the after percent composition values that we obtain. So let's get started. So here in this lab right here, there will be three types of sample, and these are the assignments for the sample. If your last name is from A to H, you will be working with the mixture 1. Versus if your last name starts with I to M, you will be working with mixture 2. And lastly, if your last name is from N to Z, you'll be working with the mixture 3. And here are the masses of the sugar that we are weighing out to make up this mixture. So if you have the mixture 1, you will have 12.533 grams of sugar. And if you have the mixture number 2, you have 10.045 grams of the sugar. And lastly, for the mixture number 3, you will have 7.503 grams of the sugar. And now the iron. If you're working with the mixtures 1, this would be the mass of your iron. And if you are sample 2, mixture 2, this would be your mass of the iron. And similarly, this would then be the mass of the ions filing for the mixture 3. And lastly, the sand. So please read this value right here to obtain the mass of your sand. And once we have weighted out the iron filings, the sugar, and the sand already, we'll be combining all of them into this Ziploc bag right here, and we'll mix all of them together to produce this mixture. So this will be the mixture 1, the mixture 2, and the mixture 3. Now, for each of this mixture right here, we'll be taking out about a third of this. So we weigh out a certain amount of this, and we take out only a small amount of it, but not the whole value. So please keep that in mind to then separate them. So let's now go over an example of an actual percent composition calculation. So let's say that in our mixture, and again, this is an example and not based on the previous data that I have shown. So let's say we make a mixture by weighing out 4.1885 gram of the iron filings and 12.5110 gram of sugar and 25.0992 gram of the sand. When we combine all of this together to produce our Ziploc bag over here, we would now have 41.7987 gram. And this would then be the mass of the entire sample. Now, how do we then calculate what would be the percent composition of each of this component? It will then be done as follows. The percent of iron would then equal to the mass of the iron filings divided by the total mass of the entire mixture multiplied by 100. So in this case right here, we have 4.1885 gram of iron, and we divide this by the total mass down here, 41.7987 multiplied by 100. And this would then equal to 10.0206% of iron by mass. And similarly, by taking the mass of the sugar divided by the total mass, this would then become the percent compositions of the sugar. And lastly, by taking the mass of the sand and divided by the total mass multiplied by 100, we'll be able to obtain the percent composition of the sand in this mixture. And when we add all of this together, they should equal to 100%. So here in this case right here, make sure you keep track of sig fig and round based on rule of significant figures. So in this case, the top value have 5 significant figures and the second value have 6. So we should be rounding to 5 significant figures. And this would then our actual percent composition. The reason why this is the actual percent composition is because we make it and we weighted this out, so we know how much of each of the component that we have. So this value right here become the actual percent composition of the individual component. Now, once we have this mixture already, we're now gonna take out a small section of it. And as you can see right here, this mixture right here do not look very uniform. So when we take out a third of this, we may not be taking out a very homogeneous sample of this mixture right here. So therefore, in the actual, in the experimental percent composition that we'll be obtaining, it may not be the same as the starting out actual percent composition. So let's say here, next we take out a small sample. In this case right here, about 10.049 gram of this mixture 1 and 10.055 gram of the mixture 2 and this much of the mixture 3. So this is the amount that we're starting out with. And now we will proceed and separate the iron, the sand, and the sugar from this mixture. So first, we'll be able to separate the iron filings from the mixture, that is 10 point something gram over here, 10.049 gram over here, by using a piece of magnet. Because we know that irons has magnetic property, so they basically stick to magnet. So by putting a magnet over the top and move it around, this magnet right here will be able to attract all of the ions, but they do not attract the sand or the sugar. So therefore, the sand and the sugar will left behind, but only the iron will be removed. So that's how we can use the differences in the physical property to remove the iron from this mixture. And after we have removed this iron already, we'll put this on the weighing boat, and this would then equal to the mass of the weighing boat. Please note that this mass right here is the mass without the weighing boat, because it has been turned with the weighing boat on top of it already. So this corresponds to the mass of the iron. And now for the rest of the sugar, And the sand will be able to separate the sand and the sugar by using the solubility differences in water. So we know that sugar dissolves in water, but sand do not. So here in this case right here, for the remaining sugar and sand mixture, we will then add water to it. And in this case right here, we add some coloring to this sugar right here to make sure that the salt, so the sugar would appear to be green, so that way we know where the sugar is. And in this case, we can see that the sugar is now dissolved in the water. And by filtering out the sand and only collecting the liquid down here, this is when where our sugar would be. And the rest of the sand will then be stuck on this filter paper. And by drying this filter paper and weighing out this filter paper right here, we'll be able to figure out how much sand that is present in a mixture. Now, we will not be able to measure the mass of a sugar directly, but knowing the fact that this consists of three components of the iron, the sugar, and the sand, by knowing the mass of the sugar, of the iron and the sand, we can figure out the mass of the sugar. So the mass of the sugar is then equal to the mass of the mixture minus the mass of the ions and minus the mass of the sand. So that's how we can determine the mass of the sugar. So here are the actual data for your lab. So this would be your sample 1. If you will assign sample number 1, then you are taking out 10.49 gram from the mixture, from the larger mixture. And if you sample number 2, this is how much that you are taking out. And these are the data right here. So if you will assign mixture number 1, this is the mass of your iron. And if you will assign number 2, this would be the mass of your iron. And here the mass of for the mixture number 3. And this would then be the mass of the sample 1 right here. So this would be the weighting bulk only. And this is the weighting bulk of the paper. And now we are interested in the mass of only the sand. So therefore, make sure to figure out the mass of the sand. You have to take the mass, the combined mass, and this is the combined mass of both the filter paper and the sand add together. Subtracting the mass of the filter paper, that is how you'll be able to obtain the mass of the sand. And here will be for the mixture 1. And this will be the data for mixture 2. And this will be then the sand data for the mixture 3. And the sugar would be in here, but of course, by taking, taking the mass of the entire mixture that you took out, of the smaller sample that you took out, minus the mass of the sand and the iron, you're supposed to be able to figure out the mass of the sugar in here. And once you have obtained those data already, it is now time for us to calculate the experimental percent composition. And the experimental percent composition is basically the mass of each of these components divided by the mass of that smaller sample that we took out. And we took out, let's say for example, that we took out 10.011 gram. And in this 10.00 gram, we have 0.9585 gram of iron. To then figure out what is the percent of the ions, then we'll be taking the mass of this iron that we recover divided by this total mass multiplied by 100%. And this would then become the experimental percent composition of the iron filings. And similarly, if after we have dried the sand already and we weigh the sand, let's say we have 6.0145 gram of sand. To figure out what is the percent composition of this sand, we'll take the mass of the sand divided by the mass of the sample that we started in the separation. And this would then equal to the mass of the sand and the percent composition by mass of the sand. And this would then be the percent composition by mass of the sugar. And once we have done both those types of calculation already, we can now figure out what is the percent error of our lab. Now, so at the beginning, let's say that originally when we first started out making the larger sample and we calculated the actual percent composition or the original percent composition, this was the actual or the original percent composition. And after we took out a smaller part of it and then separate them to determine the experimental percent composition, this is what they would be. And we can then calculate the percent error because we can see these two values right here are not the same thing. They're close together, but they're not the same thing. And there is some error in it. And to calculate the percent error, you would then basically take the original percent of the iron that we started out minus, so this is basically our experimental value, and this is our actual value divided by the actual value and multiplied by 100. And that's how we can calculate what would be the percent error, which is 4.45. And similarly, by taking the actual the experimental percent composition of the sugar minus the original percent composition of the sugar divided by the actual or the original and multiplied by 100, this is how we can calculate the other percent errors. Now in your lab report, there is one table where it asks for the group value, and because we're not able to interact with other people and obtain the value from other people, so you can go ahead and ignore this data table over here. And please submit this lab report by answering the rest of the question and so on all of the calculation.